Buenos dias, bienvenidos a IDR. We're starting our session this morning. Welcome to Madrid. And we have a very packed agenda today, so we'll try to keep things moving smoothly as we can. Sue will be joining us remotely, somewhat erratically. Um, and we have, as I mentioned, a very packed agenda. Let's go ahead and go through the working group status. The first thing is obviously we have our Note well. This is your first time seeing this through the IETF week. If you are a new to IETF participant, you are expected to be familiar with the things in this page. You're also, as IETF participants, expected to respect and abide by these things. Now, these are binding things as part of your participation. Please be aware what they are. And very similarly, we have anti-harassment procedures in IETF. You're expected to be respectful of your conference colleagues. Debate the points, don't debate the people. So as you can see, we have 11 agenda items on here. We will have a brief discussion about the charter work as part of the chair slides. And as you can see, we also have a second session on Friday. On Friday in particular, to be interested is that we will be talking about updates to the core BGP RFC and moving that to standards. Hitting the items, as I mentioned, we are going through rechartering just like a lot of the other groups in IETF. We will have a brief presentation on that and a brief set of comments from Ketan. The actual criticisms of the charter proposal should go to the mailing list for public debate. So we will not be taking time for the mic on that today. We are trying to move BGP through the standards process, and John Scudder will be giving a presentation on Friday for that. As chairs, we also do apologize. We have had a lot of personal life things happening to all of us that have made us run a little slow. If you see that something has been stuck in the queue that you think should get better attention, please let us know. That said, all of the work for the working group is supposed to happen on the mailing list. And we're seeing actually very little discussion, especially for a number of the proposals that we'll be talking about today that are happening there. So please don't just come here to the sessions and present once a quarter. We want to actually see discussions, and we want to move these documents to completion. And the best way to do that is do not try to use the chairs as anything other than document shepherds. We are not your editors. We are not your hidden authors. When we get put in that position, even though sometimes it's helpful for moving things forward, it actually makes the entire working group run slower. For specific items, we do have a code point refresh for the white community draft. That is ready to move forward in the RFC process, and I'm currently the holdup for exactly the reasons we were talking about in the prior slide. SD-WAN discovery, we have some comments related to tunneling that need to be addressed that have come from Alvaro. Ketan has provided his own feedback, and Sue's in the process of working with the authors. Ketan has a brief comment on this.
So Alvaro and I did discuss this, and we have some suggestions. Don't want to take up the mic time here in the session, but we'll set up something with the chairs and the authors on it to see how we can move this forward.
Okay, great, thank you. The version capability draft did not get adopted. We are sending that off to the independent submissions editor. We had actually started on that track, but the author requested to see if we could actually try once again to move it through a standards track. VPN prefix ORF is really at the finish line. The authors have been very responsive. We're very grateful to that. We are targeting getting the last of this integrated, I think, during IETF week, and we should hopefully be able to send it off to the ISG very shortly thereafter. The metadata draft has got its early allocation done, and hopefully that it will be continuing through publication. Hopefully and then it's giving the thumbs up, so that's looking good. Sue is in the process of taking care of BGP CT SRv6, so we'll hopefully see that moving forward as well. BGPLS SRVTN MT is at the ISG. It has actually gotten some feedback and revision needed from the authors. That's looking like it may be one part cleanup of the informational portion and splitting it from the Spring document, and one part potentially adding in procedures that might move it from informational to proposed standard. So keep an eye on that. The policy NRP, the working group last call closed. There are spring dependencies there, and there are discussions happening with the spring chairs. And you're starting to note a theme as we have BGPLS being used for more things related to segment routing. Our dependencies and coordination with the spring working group becomes very complicated. So this will be an ongoing thing for IDR and spring to work through. The policy path segment is also about ready for working group last call. Sue's in the process of doing shepherd work that is preceding that. We have several documents that are hung up on various things. So the FISO IANA work is hung up on BFD strict mode audits. That is one of my tokens. Strict mode itself is hung up on me. We're seeing this vast dependency tree where I'm the blocker for some of these things. Drive community's got a few feedback components that need to be integrated, and flood reflection is waiting for an update. This is our current adoption queue. We should be hopefully working through some of this early after this IETF, along with whatever work we pick up this session. Flow spec v2 has been blocked on Sue and I making forward progress on the core spec. And here's the series of documents that will eventually make use of flow spec v2. On specific work items, the linked local capability draft, there was extremely strong interest on the mailing list a little while ago. Donatus has done wonderful work integrating all of that commentary from the list. And we have exactly one known issue at this point relating to IBGP and route reflection behaviors. Please take a look at that thread. Please respond to it. And we're likely to do working group last call shortly after this IETF. Speaking of what was hopefully last calls, we also thought we were done with link bandwidth. There's no presentation at this IETF, but we've had a last minute request from the best chairs to consider taking the cumulative link bandwidth work that is done in BESS to actually incorporate that into the core document. Please see the list discussion and offer your own opinions. Very similarly, part of that work is how do we take a non-transitive extended community and throw it over EBGP boundary. It's been the chair decision that this work really is a small update to extended communities, and we're likely to need a 4360 BIS. Please offer your opinions about the contents of the link bandwidth and also whether we should actually do the merged use case. And two things that we should actually consider picking up as work. We are regularly running into integration issues with other working groups, such as BESS, such as GROW, anything that touches BMP, BGP, and we could probably benefit from having a very short document of some sort that is a list of definitions of BGP terminology. This is the drafter wiki. That's to be determined. If you're interested in helping drive this, please let us know. And as I just mentioned, extended communities does need to have a small BIS relating to transitivity behavior. The chair should not own this. We're too busy. If there's anybody in the room here or on the list or on MeetEcho that wants to actually be an editor for this small piece work, please let the chairs know. So that is our status slides. We'll be moving into charter. Did you want to take this care?
Sure.
You have to turn on your mic. Red button. Red button.
Hello. Yep. Super. So next slide, please. Where do I go? Super. Here is the link to a charter amendment that's been worked upon. Thank you, Ketan, for coming up with the Strawman proposal for or taking a first cut at the charter. Basically, this new charter has four different main points to cover. One is to cover whatever that is going on in IDR, all the ongoing work within IDR. The second point that charter covers is a good balance between coverage as well as openness, and that leads us to a good structure to allow incremental charter amendments in future as and when it's needed, and this would be done on a need to do basis between chairs and ADs. And last but not the least, we see a lot of cross working group BGP features being developed, and this is where we would want to facilitate deep technical reviews as and when needed. Yeah, next slide, please. Um, Things to watch out for in the charter. Everything that is ongoing should not be a surprise here, but the charter text does cover it, basically underlay routing as well as a limited amount of overlay part, adjacent routing information in that context, all the core protocol features as well as protocol extensions that have been done usually in this working group. And last but not the least, different areas that are adjacent to BGP. This is a text that would be particularly interesting if you're looking to review what kind of incremental amendments or what does Charter allow to sort of amend in future for the newer work that is going to come in. And the text is here written, which is quite flexible to allow newer work to come in. Next slide, please. Yep. And then we do want to facilitate cross working group reviews. This would be done on a much broader scale. This would also be done on a need to do basis, as and when we think certain working groups would benefit from the review as needed, we would request the review. So the detailed charter text is listed on the uh, wiki pointer that we just gave out, or GitHub. Please review, and um, we will send out an email, but ideally it will be good to get a working group review within 2 weeks post the IETF. So looking forward to some discussion on the mailing list. Yeah, thank you. I believe that's my last slide.
Okay, Gaetan, did you have any quick comments? Okay, we're good. We will move into our first item then. Where's the clicker? Yes.
Okay. Good morning, everyone. Zheng Qiangli from China Mobile. Today, I will present two documents. They are both better. Okay. Today, I will present two documents. They are both about extensions to BGP protocol. The first one is extension to BGP flow specification, and the second one is about extension to BGP SR policy. So this is the first one, BGP flow spec redirect to second routing policy. So while another document on the same topic, some guys may know that BGP flow spec redirect to second routing policy is being defined by this working group. There's a working group document that is currently being advanced. But that working group document is informational and no new standard action is introduced in it. That document mainly illustrates a potential use case using the existing filtering rules and actions defined for BGP flow spec version 1. And this document, my document, extends BGP flow spec version 2 by introducing two new standard traffic filtering actions. So we use BGP community container attributes to encapsulate the actions introduced. The figure shown in this slide is the format of the action sub-TRVs in the BGP community container attribute. Two new sub-TRV types are requested to be assigned by ANA, one for redirect to a second routing policy action and the other for a second routing verse 6 seat action. this is the format of the value field of the redirect to sample routing policy action. It consists three parts, and the policy color and the endpoint are used to indicate the sample routing policy the traffic will be redirected to, and as defined in RFC 9256. The endpoint of a second routing policy can be an IPv4 address or an IPv6 address. So we use the flag field to indicate this. Currently, there are two bits are defined in the flag field, the S bit and the F bit. S bit means 6, which indicates that the endpoint is in IPv6 address, and F bit is used to indicate the endpoint is the S bit is used to indicate the endpoint is IPv6 address, and the F bit is used to indicate that the endpoint is an IPv6 address. Okay. So this is the format of the value field of the SRv6 seed action. It consists of two parts: the action part and the SRv6 seed part. The action part is used to tell the head end what actions should be done with the SRv6 seed. At present, only one action encapsulated is defined in this document. This seed action is optional. It is used in conjunction with the redirect to SR policy action only when necessary. For example, when the last seed of the sample routing policy path is not USD flavored. USD here means the ultimate segment decapsulation. So the head end should encapsulate an additional SRv6 seed to instruct the endpoint to decapsulate the outer packet head, right? So we need a seed action to tell the head end node to do so. So for the next steps, further reviews and comments are welcome and appreciated. Many thanks.
Any questions from the room or online? Okay, we see nothing in the queue. Thank you for the presentation. And the working group should note this is one of the first things that are trying to use the community container for FlowSpec v2. We're going to see this as a more common pattern as we work through the FlowSpec v2 work. So your attention there is appreciated.
Okay.
Thank you.
Let's move to
And your next presentation as well. Excellent. Makes it easy. Control. Slides and even better. There we go. Insert policy. Now to get the back control. 1 second, please. Now you have control.
Oh, yes, it works. So this is my second document. It's the extension to BGP subrouting policy. BGP SR policy extensions for performance of web path selection. First of all, the scenario to be addressed. Please look at the picture. PE3 is the head end node. It's directed by the as our policy computation and provisioning system, P3 sets up two policies. The first one is from PE3 through P1 to PE1, and the second one is from PE3 through P2 to P2. And the performance, the overall performance of the first policy is 20 milliseconds, and the performance of the second policy is only 12 milliseconds. P3 is instructed to steer the VPN traffic over second routing policy. And P3 learns the same VPN private rules from P1 and P2 because C1 sends the same private rule to them. And according to the current tie-breaking procedures of BGP, P3 will select PE1 as the next stop for next hop for the VPN rules because the router ID of P1 is smaller than that of P2. Unfortunately, the performance of policy one is not the best. The performance of policy two is better because the overall latency of this policy is only 12 milliseconds, right? So we need to extend the BGP second routing policy to add a metric to a metric TRV in this policy to let the policy computation and provision system to tell the head and node the performance of the policies it generates. So this is the extended BGP as our policy encoding structure. Metric is added in the tunnel encapsulation attribute. It belongs to the candidate path. And this is the detailed format of this sub-TRV. Currently, there are three types of optional performance metrics in this in the metrics of TRV. The delay metric, the bandwidth metric, and the reliability metric. They are optional, and we use the flag field to indicate which metric is present. One and only one metric should be present. So for the policy computation and provision system behavior, the system collects network status information, including performance metrics related to each link in the network. And then it computes the second routing policies based on the service requirements and network status. Then it encapsulates the performance metrics in the overall performance of the policy in the metrics sub-theory introduced in this document. Last, it provisioned the BGP update message and sent them to the head-end node. For the behavior of the head-end node, the head-end validates BGP update message and extracts performance metrics from the received messages. It stores the performance it received in a local database for subsequent path selection, and then it selects the best second routing policy, preferring the segment routing policy with optimal performance metrics. At this step, the BGP type breaking procedure needs to be updated. We will show it in the next slide. Last, the head end will update the routing tables, populate the routing table based on the selected SR policy to populate the correct next hop for the rules. And this is the updated BGP type breaking procedure defined in RFC 2261. A new step is inserted before step E. Step E is to compare the IDP cost of the IDP cost of the route and consideration. The step E0 we inserted is to compare the performance of the segment routing policies corresponding to the rules and the considerations. In detail, it has three sub-steps. Firstly, if any route have the color extended community attribute with identical values, the BGP module will remove from considerations all routes lacking that attribute. And secondly, that module will compare the segment routing policy corresponding to the remaining rules. If any segment routing policies include the sub-TRV, the metric sub-TRV introduced, we will the model will remove from considerations all rules whose corresponding segment routing policy lack this sub-TRV. And thirdly, the BGP module will remove from consideration all rules whose metric sub-TRV are not the best. For the delay metric, the biggest value is the best, and for the bandwidth metric, for the delay metric, the smallest one is the best, and for the bandwidth metric, the biggest one is the best, and for the reliability, the smallest one is the best. You can read the document for the details. So that's all for this document. Further reviews and comments are welcome and appreciated.
Okay, do we have any questions for the queue? If not, I'm going to proxy a few things from the chat. Okay, so I'm not seeing anybody in the queue. So thank you for the presentation. There is actually quite a bit of discussion happening in the chat for MeetEcho. Please take a look at that, and anybody making the comments to the chat, also please take them to the mailing list, covering a couple of the points that are most important. One comment is the format for the PDU for the types could probably use a little additional attention. We've had comments like, bandwidth is maybe a little small and some of the fields are less well defined. We realize that you're trying to make a consistent field that is selectable, but that encoding may be not the best one you want to use.
We can discuss the detail in the mailing list.
And the mailing is, yes. The other comment to have at the microphone here for yourself and also for the room, we will be talking about other metric fields and options in the rest of the presentations. Next top capability for generic metric is an example. Your proposal is SR policy specific. And you're also recommending changes to route selection, as is the generic metric one. Changing the route selection is a very problematic thing for BGP, and we'll want to have careful discussion about it.
Yes, we should do it.
Yes.
Thank you very much.
And seeing no further questions, thank you. Oh, I do not see anything in the queue from here. I see it now.
Okay.
Changguang?
John Scudder, HPE. So forgive me if this is in the draft. I did look at it, but just briefly. The thing I'm confused about is this metric thingy. Generally, the metric to reach a given point in the network is going to be different from different points in the network, right? So in this case, we're advertising a metric that is to be understood as, yeah, can you tell me like exactly from whose perspective that metric is being advertised? If the question's not clear, we can discuss it later offline.
So,
Yeah, okay.
Okay,
Why don't we take it offline?
okay, just send your question in the mail list. Okay.
I'm
So
sorry?
Send your question in the mail list. I will discuss it.
Okay, that's fine. Thank you.
Okay.
There is one final Changguang.
Hello, can you hear me? I'm Yujia, and there are some problem for my account, so I use my college's account.
We can hear you.
And yeah, okay, thank you. And I have some question about the first BGP flow spec presentation, because we also focused on this topic. So I want to ask, is there any experimental verification of the effectiveness of the SR policy action, and how the effective is it? And another question is, does it work for both FlowSpec V1 and V2, or just for the FlowSpec V2? Thank you.
My intention to BGP flow spec is for flow spec version 2, and the action is used to direct the specific policy, specific traffic to a subrouting policy that we want to use. So the head end will do so when it receives the specification from a async controller, for example.
Okay, thank you for the answer. And we also do some work about the flow spec, and we are trying to propose a payload filter. So we also hope the IDR working group can consider the more IP filter draft as a priority in its work process, and accelerate the schedule for the some other draft, such as the payload filter or the SR policy filter. Thank you. And maybe we can discuss through the mailing list.
Okay, thank you.
Thank you.
Thank you again. Thank you for the comments. Next presentation, BGPLS advertisement, DE policy, performance metrics.
Can you hear me?
We can hear you. Let me pass you the slide control. You have control now.
Okay. This is Changwan Lin from H3C. This job about the BPLS advertised of SR policy performance metric. So background, current SRT schedule involved three metrics. First, the link metric, the performance metric of the link reported by BPLS topology. The second, the service metric, so the metric requirement of the pass by the service. Another metric is calculated metric, the metric of the computed pass. In fact, there is also a real performance metric of the pass. which currently cannot be reported by BPLs. As we can see in the figure of the right, the controller send the SR policy to the head end, and then it monitor the traffic pass through the SR policy. If the latency or packet loss reached a certain slow, it triggered a pass switch for the SR policy. Alternatively, when link delay or path loss rate changes, the top range changes can be reported by BPLs, and the controller can perform the path calculation. For the control, the key challenges are it cannot clearly show the SR policy path performance metric, and it needs to detect the path metric change and quickly re-optimize the path. Therefore, this draft proposed reporting the performance metric of the SR policy by BPRS. At the head end, the delay and the packet loss rate of SR policy can be detected by step, and then can report it to the control by BPRS. In RFC 18571, early specified PPLs to advertise IGP performance metric. So there is a lack of a mechanism description for PPLs how to advertise the SR policy performance metric. This is the BPLS extension. The first part, we used the existing TLV defined in RFC 18571. This can be reused to advertise the unit direct performance metric of a SR policy. The second part, we define a new TLVs to advertise by direct performance metric, such as bidirectional delay or link loss. Finally, let's examine the specific location of performance metric information in BPRS. An SR policy is advertised through the SR policy CPNRI. Multiple segment list can be included in its attribute. Under the segment list TLV, we add a new performance metric information. The first part is about unidirectory performance metric. The second part is about the bidirectional delay or packet loss. The performance metric include both bidirectionally and unidirectionally. That's all. Any questions, comments are welcome. Thanks.
Zafar, you have the cue. And we're running already a little bit behind, so let's try to keep this brief, please.
Yeah, I mean, the one comment I have that we have in draft IETF IDR BGPLS policy, which does list the SR segment list metrics of TLVs. I think it'd be good to contrast in this is what is missing, and most of the time, like this is unidirectional. This is about policy, so I don't understand what link delay really means, unidirectional link delay, and these use of the link here. But anyway, I'd be happy to talk offline a bit more.
Yes, thank you for your question. There are two reasons why we advertise performance metric in BPLs. Uh, when devices are we need the bidirectional metric as the key fact in past calculation decision. For BPL's intentions, it can provide a performance metric, help the controller to make a better decision or optimize the path efficiently.
We can take it offline, but policy is unidirectional.
When the device are not configured PTP or NTP, the measured performance are bidirectional. When you configure the PTP or NTP, the measure metric could be unidirectional. But the controller need to know the performance is bidirectional or unidirectional.
It's okay. We're running out of time, so maybe we take it offline. Thank you.
Yeah, thanks.
So thanks for that presentation. Number 4, I think. Okay, our next presentation's on BHP SR policy extensions for path scheduling.
Hello, can you hear me?
We can hear you, Li Zhang.
Yes, thank you. Hello, everyone. This is Li Zhang from Huawei. I will introduce the BPS party SR policy extensions for path scheduling on behalf of my colleagues. And next slide, please. Can I control it? Oh, I can control. Okay. Okay. So what's new in this version based on the comments collected in the last meeting and also the Shepherd review, we did the following updates. The first one is we added the definition of epoch, which is the 1st January 1917. And we also added the description for the case when the schedule time information sub TRV is carried at both candidate path level and segment list level. And we also added a description for that the scheduling time information sub TLV is currently used in SR policy tunnel TLV and maybe extended to other tunnel TLVs in the future, but it's not in the scope of this document. And we also add a description for when the head end does not have the capability to deal with the schedule time information sum theory. And we also added some added the error handling and fault management section, the manageability consideration section, the security consideration section, and also do some editorial updates. And okay. Okay, so maybe this is still new for some people in the meeting, so I would like to introduce the motivation again. There are two tactical use cases. The first case is the network with discontinuous links. In some cases, the links between the network devices and the network controller may be very weak or intermittent. This is very typical in resource preservation and dynamic reachability network defined in RC 9657, where the devices or links may only work at a specific time point. So in these cases, the real-time SR policy advertising just before changes occur maybe not maybe untimely and even causing packet loss. And the other case is the networks with frequent topology change. There are also some cases the topology change very frequent. This is very typical when the number of the network entities is very large. For example, we consider a dynamic reachability network with hundreds or thousands of nodes. In this kind of work, the path changes very frequent, and it poses great challenge to the network controller. So we extend the BPS policy as a policy with schedule time information. The schedule time information sub-TLV can be applied to a candidate path or segment list to indicate the valid time for each candidate path or segment list. So how to use this extension? It can be divided into two steps. The first step is to advertisement. The SR policies and the associated schedule time information sub-TLV are computed by the controller or a PCE and originated by a BGP speaker on its behalf. And each schedule is identified by a schedule ID, and the controller or PCE ensures the schedule ID unique within a specific SR policy. For the head end, when it receives the SR policy with the schedule time information, it should to check the uniqueness of schedule ID and also the rationality of time parameters. If a SR policy encapsulates the schedule time information sub-TLV at both candidate path level and the segment list level simultaneously, then the sub-TLVs at the segment list level should be used. And the header can then enable or disable the candidate paths or segment lists based on the schedule time information. Okay, and as this work is based on the draft SR policy survey draft, so the error handling actions defined in that draft is also applicable in this draft. And if a BGP speaker receives SR policy that with the schedule time information sub-TLV, but it does not have the capacity to deal with that schedule time information sub-TLV, then the SR policy should not be considered usable. This is consistent with with section 4.2.2 of SR policy survey draft. And the validation of schedule time information sub-TLV should also be performed to determine whether it is malformed or invalid. If the schedule time information sub-TLV is invalid or malformed, then the SR policy must be not used and should be handled by treat as withdraw. This is also consistent with section 5 of draft IDR SR policy survey. Okay, there are also some questions collected in the last meeting and Shepherd review. The first is why not just run schedule on the controller and to send the new policies to the devices when the topology changes or new path is calculated. This is described in the motivation section. In some scenarios, the connection may be not stable, and yeah, some other scenarios, the topology changes very frequent. So the controller need to deliver new SR policies very frequent. So in these cases, running schedule on run head end is better than on the controller. The second question is why not? What will happen if the receiving node head end does not support this capacity? This has been described in the previous page. It must not use the SR policy. And the second question is what will happen if the connection between the head end and the controller is interrupted? Will this route be withdrawn? Okay, we use the graceful restart here to retain the rules received from the controller when the connection is interrupted. Another fourth question is the length of start time and time is 64 bits. While we have checked this currently the POSIX doesn't define the 64-bit time tier. So, but 32-bit time tier will wrap around on 98th January to 2038. So, maybe this question still need to be real for future. Okay, so is this draft ready for working group adoption? And we also welcome for comments and suggestions. That's all. Thank you.
Zafar has the cue.
Zafar Ali system. So have this discussed with the TVR working group? Are they asking for this enhancement? This
No, we didn't have a discussion with TVR working group.
Okay. And the second question is that do we feel that like loading BGPLS is the right thing, or is just the configuration data that can come from a correct data model that the TVR working group will define for use cases like this if they find a need for this?
Uh, well, the TVR is only define the data model and for the how to use these data models. I think it has been some description in the TVR requirements and applicability draft about using using TVR data model in the centralized scenarios. So I think it has some relationship with the TVR's current work.
Yeah, I think that there's a relationship with this working group and needs to be sorted out. Thank you.
Yeah, so Ketan, you have to keep it short.
Yeah. So as a routing AD, just because the draft is asking for adoption, I believe there was a similar draft in PSEP, and there is an existing RFC in PSEP. I think that Drew pointed out. Because this may be going into multiple protocols, we need to ensure that there is some consistency in the encoding. That may be something based on the model in TVR, but I would think that works needs to be done before this moves ahead to ensure consistency, or after adoption somewhere.
Adding my own chair comment, TVR certainly doesn't own time formats across all of IETF quite yet, but certainly normalizing is a great idea. The existing PSEP work is a good example. We want to have as few of these things, and as somebody who does more than a little bit of Yang, that's another example of where we want consistency. Thank you for the presentation. Zafar is taking the
Thank
next
you.
one.
Hi guys. So I'm going to present this seedless optimization advertisement draft on behalf of my co-authors. So just a review of the problem statement. So SR policy takes traffic from the SRT headend to the endpoint. There are cases where SR policy carries the endpoint node SID as part of the policy traffic steering. But then there are services that are steered on top of it. And one example is the BGP service. And in the cases when policy ends with the endpoint node SID and a policy and service steering on top of it also had or carries that traffic to the endpoint node SID, now you have two back-to-back node SIDs or two back-to-back SIDs for the endpoint of that policy. Example, I gave the example of service SID, but there is also when you're steering traffic to a binding SID, the binding SID uh, uh, B SID is part of that endpoint. It takes you to the endpoint. So EP is another example. So in cases when you carry back-to-back SID is inefficient from MTU and compression point of view. So um, basically, and the other point is that not in all cases, the endpoint node SID could be excluded, because endpoint could have UA, and in that cases it cannot be excluded, or the traffic that is steered on top of the policy is an MPLS, for example, in MPLS interworking case, then it cannot be excluded. So there is, the solution is really in here, in this particular draft, and there's a complementary draft to this in PSAP and a Spring Working Group, is to mention in BGPLS whether a given endpoint node SID is included or excluded in installing the policy. Since last revision, there were comments, and one of the comments was to have a Spring Working Group draft that glues the IDR changes that are needed and also the PSAP changes that are needed together. So there is a document written in Spring that would be that is on agenda for Spring at this IETF, and that glues things together. And there was another comment about making the flag consistent across PSAP, Spring, and IDR. And we basically renamed the flag as ENS, endpoint node SID suppression flag. And in the BGPLS extension that we talked about here, where a node is mentioning whether the endpoint node SID is suppressed or not, or SRT hidden, carries this information in SR candidate path state TLV, and that's the TLV that is specified already in draft IETF IDR BGPLS SR policy. And the flag, when it's set, mentioned because it's endpoint node suppression flag. So that means when it's set, that means we are actually suppressing, and when it's unset, the suppression is off. I would like to get some discussion in the adoption for this, because the last time, the reason for this document to not move forward was there was no Spring counterpart, but it has been added now.
So for the adoption call, please take the mailing list. Let's get our discussion there. And thank you for incorporating the prior feedback.
Thank you.
Any questions in the queue? I see nothing.
Thank you.
Thank you so far.
Okay, can you hear me?
We can hear you. Let me pass you slide control.
Okay.
You're
Hello,
all set.
everyone. I'm glad to be here to present this draft. The draft is about distribution of device discovery information in NVMe over RockV2 storage network using BGP. Currently, many enterprise data centers utilize FC switches and FC SAN to support high-performance business scenarios such as core business systems, databases, and AI or machine learning applications. However, FC switches face challenge, including higher cost compared data center switches and maintenance difficulties. With the increasing rocket technology in high-performance networking, NVMe over RockV2 is a popular solution of storage network based on Ethernet for communication performance. However, there remain several challenges when implementing NVMe over RockV2 in high-performance storage. The first issue is that discovery between host and storage server systems still requires manual intervention, lacking an automatic discovery mechanism. The second problem is that the reaction speed is slow when a device goes online or offline, making it hard to realize hot plug and fail over. So how to do the automatic discovery when host and storage device connect to a Rakuten network? The network automatically discovers the device through LLDP and notify the servers to establish connection with the storage device. And then the discovery information is distributed to other access switches by the access switches in the fabric. Finally, other host and storage server system get the discovery information notification message from the switches which they directly connected with. So the host and the storage system knows each other get online or offline. So when the storage subsystem goes online or offline, the remote host needs to quickly detect the status change and perform operations such as establish connection. This process involves the one is LLDP advertisement between the host storage subsystem and the switches. The second is information between switches. The third is repeat failure detection. So how to transmit discovery information among switches? This draft proposes extending the BGP protocol to achieve inter-switch message. The workflow is as follows. All the success switches are BGP speaker, and the device discovery information is exchange as BGP rules among them. The RR can be used to reduce the number of BGP connection. So a new BGP network layer reachability information is defined. The norm for NLRI has two types. Type 1 is device discovery NLRI, and type 2 is device zone. The type 1 uses to carry the discovery information of directly connected device in storage network host and the host storage subsystem are generally divided into several zones. So type 2 used to distribute the zone configuration of a device and allow to discover and communicate with each other in the same zone. So type 1 sub TLV has consists of 5 components. Router ID, MAC address, and port name are important, which are the part of the prefix in the NLRI. The device info is the specific information of the connect device, and its connecting port contain some TLVs. The device info sub TLV supports multiple types such as IPv4 address and IPv6 address TLV, raw type TLV, and so on. The raw type represents the role of the device, such as storage subsystem, host, and the device, which can serve as both host and storage subsystem. Type 2 subtlety consists of 5 components. The root ID represents the access switch with horizontal the NIRI. The zone name which the connected device belong to. So root ID IP address and zone name are important, which are the part of the prefix in the NIRI. That's all. Welcome any suggestion and feedback.
Okay, thanks for the presentation. Do we have any questions? Jeff, you should join the queue. You're chair, you know that.
Jeff, answer NVIDIA. Quick question. Why do we need reachability at networking layer? For all our requests, you need to open QP. There's enough machinery in RDMA to figure out who is on, who is off. Why do we need this information at layer 3?
Okay, thank you. I think the issue you raised is quite valuable. It hadn't occurred to me before. Perhaps we could discuss this problem by email.
Stefan, you're next. Stefan, you're in the queue and we do not hear you.
Yeah, I need to unmute. That will be better. Sorry. Can you hear me now?
Yes.
Yeah, speaking as best chair, so if this works need to be pursued and if there is any interest to pursue it, likely this could be a topic that the best working group could potentially tackle if, of course, the AD agree. Yeah.
Okay, we have no further questions in the queue. Thank you for the presentation. And as Stefan is mentioning, this may be a better fit for the best working group. We'll
Okay.
look forward to hearing what you do with this presentation. Okay, our next presentation is on fully adaptive routing.
Hello, everyone. I'm Xiaohu from China Mobile Cloud. Let's talk about fully adaptive routing using BGP. Today, 10,000 GPU cluster used for AI training is common, which usually consists of 3-stage or 5-stage network. In that network, network throughput is much important for training efficiency. The characteristics of AI traffic are different from the traditional data center traffic. It's low entropy. It has a lot of has elephant flow and burst issue. If we use traditional ECMP hash approach to deal with AI traffic, it will result in low bandwidth utilization due to some degree of confusion. Adaptive routing has been recognized by the community as a valid approach to improve the bandwidth efficiency in AI networks. To achieve adaptive routing, switches need to obtain real-time information about bandwidth information associated with each ECMP route. BGP has been widely used in data center networks, so it's straightforward to leverage BGP to propagate path information in addition to the route reachability information. There are very similar drafts which talk about how to use the link bandwidth to do ESMP. But my point is this draft is intended to be used in a scenario where the external link bandwidth matters rather than the internal fabric bandwidth matters. So my personal belief is this draft is not intended for the AI network, especially for the 5-stage class AI networks. BGP-based adaptive routing mechanism called fully adaptive routing Ethernet is built on a newly defined attribute called path bandwidth attribute. It can be used in both 3-stage and 5-stage class networks. Here, example in the 3-stage class, SPI nodes and leaf nodes are fully connected using 100 gigabit link. And the server multi-home to leaf nodes. And when leaf nodes advertising the route towards server 1, it will attach pass bandwidth attributes being filled with the maximum value. Upon receiving this route, SPI node, such as SP1, will calculate the path bandwidth associated with each ESMP route. More specifically, it will compare the bandwidth value contained in the advertised route and the bandwidth associated with the link connected to the BGP next hop. And it will choose the minor value as a path bandwidth value before advertising it towards another leaf node. So when leaf node 1 receive 2 ESMP routes from both SPI1 and SPI2, it will do the same action as SPI node. It will calculate the bandwidth, path bandwidth associated with each ESMP route. Then it will assign weight to each ESMP route according to their path bandwidth value. This is a 5-stage class. In this scenario, one path bandwidth attribute is not enough. So we need to introduce another path bandwidth value. The first bandwidth value is used by a leaf node to calculate end-to-end, calculate the route bandwidth for end-to-end paths. For instance, from the point of view of leaf 1, there are 2 ESMP paths. One path is where SPI1 and super SPI 1 and 2 and SPI 3 and then leaf 3 and leaf 4. Another path is where SPI 2, super SPI 3 and 4, then SPI 4 and leaf 3. Okay. There are 2 end-to-end ESMP paths. By using the first bandwidth, path bandwidth value, leaf 1 will calculate the end-to-end path end-to-end pass bandwidth for those two ECMP routes, then do weighted ECMP load balancing. Another bandwidth was attended by super node, because from the point of view of SPY 1 and SPY 2, there are two roads to the final destination. One road from the point of view of SPY 1, one route is where Super SPY 1, SPY 3, and leaf 3 and leaf 4. Another route is where Super SPY 2 and then SPY 3 and then leaf 2 and 3, because the two paths have equal bandwidth, so it will evenly distribute traffic across those two ECMP paths. Here, it's demonstrated why link bandwidth, a single attribute, is not enough to deal with this case. The FAIR protocol described in this draft has been implemented by 2 vendors and 2 cloud service providers. It has been successfully deployed in at least 2 1 key GPU clusters. It has been verified in at least 2 very mainstream AI Ethernet chips. One is Tomahawk 5, another is Spectrum 4. These Ethernet switches with FAIR enabled has better performance, load balancing performance compared with the traditional ECMP, and even better.
Pardon, you're out of time, and you have 2 questions in the queue. So
Oh,
maybe we should wrap up.
Okay. Skip this. Okay, next step. This draft is stable enough and is ready for working group adoption core. And also early AI-NA code point allocation is needed. That's all.
Thank you. So we have 3 people in the queue. Please keep your comments very brief, and we're running a little bit behind. Stefan.
Yeah. So in my opinion, we should not introduce a new BGP extended community to do that. I think the link bandwidth is far enough. We have now, because some assumptions that you actually make about the link bandwidth extended community may have been true some months back before some updates have been done, but now we have all the tools to enable the propagation of this link bandwidth community, whatever it's transitive or non-transitive. And by the way, there are already a couple of implementations that are doing the use case or similar use case that you are describing with the existing attribute. Introducing a new extended community, for me, this will just complexify things, because then you will have to deal with what happens when you have the 2 communities. So which one will you pick? What decision you will make? For me, that will just become confusing. We have one existing BGP container that can carry bandwidth information. We can argue that it's already, I would say, attached to a path, because this extended community is part of a BGP path. So it's actually reflecting one property of this particular BGP path. So then what we encode in it is really up to a local behavior. We can do cumulation, as it's explained already in the eBGP DMZ draft. We could drive the UCMP weight computation by picking whatever formulas that we want. We can use the local link bandwidth. We can use the remote bandwidth that has been advertised. As you mentioned, we can use, for instance, the minimum between the two. We can do whatever we want, but at the end, it's just a local behavior and local decision of the box. So I'm completely fine defining that as a kind of new use case. I think it's completely fine, but does it really require a new standard for that? I don't think so.
Sorry, there's no time for responses.
Okay, you can send your question to the mailing list, and I will respond. Okay.
Tobias, you're very brief.
Tobias Wiewig, Max Planck Institute for Informatics. First, co-signing the previous statement, and secondary, from the presentation, I at least got the impression that this is very V4-centric at the moment. I think if this goes further, it should also think about like how this might differ if you're also doing V6.
Okay, good follow-up for the list. Jeffrey, actually, before Jeffrey, yes, Jeffrey's next.
Okay, Jeffrey from HPE. So we can follow up more offline, but quick comment is that with the bursty and elephant flows, your attribute may change very quickly and they may make it very chatty. There is an alternative solution we have been talking about, basically using UDP to propagate link load information, but we can follow up offline. Thanks.
Okay. Thank you. Yao, you're the last. The queue's cut.
Hello from ZT, and my question is about on page 6 that you mentioned about the switch chips. From my understanding, it seems like a software function. So is it related with chip design or it's a generic function that all switch chips can support?
Okay, because we use a per packet based ECMP, and that is only applicable to a certain type of RDMA traffic. So that needs some support from chips. Okay.
Okay, and my second question is that you said this has been deployed in the I think it's 1,000 training networks. Is there any consideration or test about the inference network?
It can be used in both training and inference.
Yeah, because
scenarios.
because the packet type or packet size is much different. So from the training or inference.
Both use RDMA.
Oh, yeah, sure.
Okay.
Okay, thank you. So we're unfortunately got to cut at least one presentation. Shahu, is Neighbor Discovery yours? Are you willing to slip your presentation to Friday?
I will leave.
You'll be
on
gone.
Friday morning. Sorry.
Okay, so you can have 2 minutes for Neighbor Discovery.
Okay.
You've already used your time.
Okay. This is a very old draft. I just want to add some new scenario about this draft. Currently, OCS is becoming popular in large-scale data centers due to several reasons, such as power reduction and capex reduction. For example, in generic three-stage class networks, SPI nodes are replaced by OCS devices, which are passive devices. So it's a low energy consumption. In this usage, by adjusting the mirror errors on OCS devices, the fully masked connection between leaf nodes can be reconfigured dynamically. In this way, by using the mechanism defined in this draft, it will be helpful to allow leaf nodes to discover each other and then establish BGP sessions dynamically. That's all.
Actually, that was quicker than expected. AC, you have 30 seconds at most.
AC Linda Marcus. I was just going to say you had some things about LDP draft. That draft has also been partially implemented, and you say it doesn't allow loopback addresses. That's not true. It allows discovery of the loopback address. What we didn't want to do, which it looks like some other people are proposing, was make LLDP a layer 2 protocol, install layer 3 routes. So, but we could easily keep BGP could learn the loopback. It could install the route. So this is wrong.
Okay,
You can.
Yeah, I believe customer have different flavors. I just noticed that their draft talking about how to use LLDP.
But yeah,
for
it did.
route
It
exchange,
said,
right?
I said we did. We said it was beyond the scope that we do not put the install LLDP. We didn't want to make LLDP a new RIB client just for this purpose.
Exactly.
But you could easily do it.
And again, great commentary to finish on the list because we have the next presentation due. Thank you, Xiaohu.
Oh, okay, the next presentation canceled, right?
Next one's is for Srihari.
Okay.
All right, so Jeff, can I go?
Your go.
All right. Hello, folks. This is a presentation, incremental update on accumulated metric in NHC attribute. My name is Srihari Sangli. I'm from HPE, and I'm presenting this on behalf of my authors. Next slide, please. Okay.
You should have
all right.
control.
So this is a quick agenda. I'm going to just talk about the updates and talk about the next steps. All right. We are basically updating this document to align with the characteristics NHC attribute, just a terminology change here. And code value 5 is assigned for accumulated metric characteristic. In this, we've supported the ability to support to add more than one metric type. A BGP speaker which is generating en route and attaching the accumulated metric TLV in the NHC can send more than one metric. And when there are more than one metrics, the receiving router can use the primary one as the first one as the primary, and then the secondaries can be used for breaking the tie when there is equal primary metric type. And of course, the local policy is always there to provide additional guidance. Another use case that this could be used is in the class topology. We could create multiple routing planes with the red plane and the blue plane, for example, with the corresponding spines connecting all the leaves, as shown in the picture. One could use the generic metric support for creating each plane using different metric type. For example, red could be using delay versus blue plane using a different metric type. And using this accumulated metric extension provides end-to-end visibility of the entire path. With that, that's pretty much this is the last slide. Any comments? Welcome.
You have time for one brief comment, Xiaohu.
Okay. Xiaohu from China Mobile Cloud. I have read your draft, and I have also made a brief comparison in the mailing list between your draft and my draft, the performance aware routing. I believe the major difference is you want to simplify the BGP car and the CT draft, and then use just a current attribute to calculate generic metric-based path selection. But my understanding is this draft cannot support generic metric-based route collection and original route collection simultaneously, right?
First of all, this is not just for CT or car address family. This is an attribute this is a TLV that gets in the NHC attribute, which can be attached to any route, any address family. Number one. Number two.
Okay, the target scenario in my draft is we want to support both performance aware route and ordinary route routing, because service provider want to support both for different customers and different traffic types. For example, for VIP customers, they can support performance aware route as a value-added service. For other customers or traffic, it's just the ordinary route. That's a major difference with the two drafts. I believe so. Do you agree?
I believe we can still use the same generic metric extension for supporting. All you need to do is attach the route, attach the attribute to the respective routes that you need. So it's all about originating the routes with the respective metric types. So we can definitely take it offline and then discuss separately on this.
Okay. Thank you.
Sure.
Okay, apparently I've been squeezing time inappropriately. Thank you, G. I was expecting to finish at the top of the hour, so we do actually have time. Changwang's presentation's next. I apologize deeply.
Hi everyone. Hi everyone. This is Taiwan. I will present this draft. This draft is about the BDP specific route reflex. So background, the current BP reflex limitation. BP only support the route reflex at the address family level, which may lead to inefficiency, especially when a BP peer received a reflex request. It must send update for all routers within the specific address family. As a result, this approach often generates redundant routine transmission, the unnecessary increasing the network load and processing overhead. Here are two common scenarios. The specific reflex control would be beneficial. The first use case, the specific type filtering. When a peer received all type of UPN route in an UPN network, it fills all IP prefix route by applying a route policy. When the route policy is disabled or changed, the peer may only need to request the speaker to send all the IP prefix advertised route. Another scenario is about the operations scenario, minimal impact on the existing operation. During network maintenance or fault scenarios, such as when BP routers on some device are incorrect. So to ensure network stability, the users may require a minimal impact on the existing network and does not want all routers to be reflexed, especially in the R routers. So it is necessary to control the scope and the impact of the BP route reflexed. We define a new BP reflex message called specific route reflex according to the BP route reflex subtype defined after 17.3.13. Then we define a new BP capability called the specific route reflex capability. The format of the specific route reflex message, we define two common reflex type. One for a specific root type. Uh, Another root reflex type for the specific root prefix. The general workflow as the follows. BP established peers and advertised the specific root reflex capability to each peer. Then send a specific root reflex message to the peer. The peer response will corresponding up message.
Chung, okay, are you done with your slides? We're no longer hearing you. 1 second while we make sure we can speak to him. Chang Wang, can you hear us?
For the next step, I saw a similar document, BP root reflex options, which expired in 2019. We can discuss with the authors of this draft and want to know why this draft does not move forward. Thanks. That's all. Thanks.
Okay, we do have two at the queue.
Krishna Swami, Cisco. There is a working group adopted draft for route refresh options. So is there anything that draft is not covering that you are coming up with this new one?
Okay, Chang Wang, we're still not hearing you. And we're no longer seeing him. I think he's rebooting his audio. We'll give him 30 seconds to figure it out.
Sorry, I lost.
We can hear you again.
So do you want me to repeat? Okay. So
Since,
there is a working
since
group
for
adopted draft, route refresh options. So is there anything that's missing in the draft that you have come up with this new one?
I haven't saw the old draft. When I saw the mechanism is similar, so I want to know why the old draft cannot move forward.
Yeah, I think, so we have refreshed the draft now, and so maybe we will take it forward, the route refresh options draft. Thank you.
Okay,
Yeah,
and while
thanks.
Maria's coming to Mike, to comment on your point, IDR did get requested to adopt that prior draft. It does substantially overlap what's being presented here today. The justification at that time for not adopting it is people were very concerned about the amount of churn a refresh-driven mechanism would be causing on BGP. And at the time, that was seen as reason to not adopt. We certainly can reopen the discussion, but we will also be bringing out the prior commentary on it. And I see that Maria's stepped out of queue. Do we have any further comments? If not, we'll pick up Xiaohu's second draft that I accidentally squeezed out. So please come. And then we'll also take lingering questions. I know that we have at least some from Kaitan.
Thank you, Chair, for giving me another choice.
My apologies for mismanaging the day. No, this has been a very complicated week already. So our second presentation, performance-aware routing. Yes.
Okay. This talk about BGP performance-aware routing. The former name is performance routing, but some guys suggest me to use this new name. Okay. The background is cloud service provider and the network service provider has a global reach, want to provide latency-based path selection as a value-added service to their customers. Performance-aware routing should coexist with the traditional routing paradigm. That's why I mentioned in the previous comment, because the performance-aware routing is provided as value-added service, so it should need additional charge. For the sake of simplicity, the BGP performance-aware routing just use a single metric, that is latency metric. Why? Because in global network, the bandwidth utilization is relatively low, especially for high priority flow, because it's use a different queue than the traditional best effort traffic. So just the network latency matters in the inter-AS path selection. No need to consider about bandwidth related issue. Don't work. Okay. Solution overview. We just use a separate software to convey performance-aware routing, which are also labeled route, just like the BPRU. Latency metric are attached as a new TLA of AIGP attribute. Before performing network latency comparison, before comparing the AS path length comparison, the network latency should be compared. Before comparing the network latency among different paths, the network latency should be network latency over the link towards the BP next hop should be ended to the latency value contained in the route. Most importantly, the path latency of the path latency to the BP next hop should be in accordance with the actual forwarding path latency. For example, if such performance-aware route is forwarded over a SR policy, the latency of the SR policy should be used for end-to-end path selection, path latency calculation. There is an illustration. For a provider has two ASs, one is domestic, another overseas, and each can use their dedicated segment routing technology. For example, one use SRv6, another enable SR MPS. And on top of that, performance-aware routing is calculated between the egress PE, P1, and egress PE, PE2. You can see from this figure, the top pass have less latency compared to the bottom pass. So P1 will select the top pass as the best pass for the performance aware routing. On top of that, two PEs will exchange service route, including VPN route or global route, just like Intel's VPN option C approach. The mechanism is much similar to the BGPLU. You can consider it as BPLU is replaced by the performance aware routing because it's also a labeled route. In addition, we can also use color attribute to associate those different layers routes. For example, service routes attached color red will resolve over the performance where routes colored red, and which in turn is resolved over the SR policy colored with red. Okay. This protocol has been implemented and is now verified in our Sonic-based NOS. Service route, including global route and VPN route, has also been verified. And this technology is scheduled to be deployed in our backbone, which consists two ASs. Next step, I think an early code point allocation is desirable for those three items. Any comments?
We do have one in the queue, and please send your INA request to the mailing list. We can go ahead and start that work.
Okay, okay.
Jeff?
Jeff Ventura, NVIDIA. I think it's fundamentally a bad idea, sorry. Highly volatile metrics don't belong in protocols in general. We've melted down a couple of networks with IGPs. This is going to be worse. You don't want something that's really dynamic to trigger best pass. And most important, there are two contributing things to latency. It's fiber length that's fixed, and you might include distribute. There is queue occupancy that is main contributor to the increased latency or reduced latency. So every time your buffer changing, you're going to send new BGP update. BGP doesn't work this way. Moreover, you've got different traffic classes and different queues on the device, and each one of them will have different latency. So you'll need to introduce the semantics into BGP, doing it per traffic class. So all in all, I think it's really a bad idea.
So just to respond to that point, during adoption work, which precedes us, those exact points were raised. So the draft should, as part of what its procedural text covers, have some level of hysteresis and damping for this type of stuff. If you think that the procedures are poorly specified, please let the authors know that. That's part of the review criteria, and it was a known item.
Okay. By the way, I want to add another point. Since Flex Algo has been popular, in this approach, there's no need for centralized T controller, right? In my opinion, using centralized opinion to calculate inter-AS pass is a little bit complex and not much acceptable for providers. Thank you.
Okay, we have no further questions for the presentation. We do have several minutes now for open questions. Yes, please go ahead and return. Xiaohu, actually, I believe the question is going to be for you.
Should we switch back to
Okay.
So you said Jefferson, you said that the draft is ready for the adoption. Your IANA section is empty. Make sure that your draft is actually in state to be discussed before you ask for adoption. That's number one.
Okay, okay.
Right.
Okay.
And in general, you're presenting fair drafts across IETF, including routing. Put more meat on the bones. There's I sent an email to you as well. There's a lot of text that makes little sense without technical details, right? So drafts are really, they're good for 0.0 to be discussed, but further they're not progressible in the shape.
Okay.
It's just a bunch of text.
You mean further discussion is needed before requesting adoption call, right?
Absolutely.
Okay, great.
You need enough technical details for people here to understand what you're trying to do and discuss them.
Okay, okay, thank you.
And yeah, it's kind of related. You really need to think, you want to include additional information in the load balancing. You really need to think where you want to have it. And the way when update traverse the network, how it mutates when there's changes and links, and think about attributes you're using.
Okay.
So I'm just going to go on the IANA thing, both for, I don't know about this, but for the load balancing draft, you did claim that there are implementations and deployments,
Yeah.
but there is no code point allocation being done for the extended community.
Yes, we just use temporary code.
You have not shipped the code, have you?
No, not shipped.
Okay.
We just use
So,
by our
so
itself.
you could actually ask for, code point allocations similar to this.
As I have mentioned, there are two vendors have implemented that. We build two network. Each network use devices just from single source, single vendor. So there are no interoperation issue. Okay.
Yeah, the concern is that if those networks become exposed to the public internet and use a code point that is not allocated, it could cause problems with other implementations.
Yes. So I believe the early allocation is needed.
Yes, we agree. We're just trying to say, don't ship code that has no code points that are not allocated.
Yes, I agree. Okay, thank you.
Mm-hmm. Okay. Any further questions for Shahu? Okay. Any further questions, commentary in the room? We have 7 more minutes before end of session. We can certainly end early. We also have time if people want to maybe use this to talk about the charter. And certainly we're going to want to have that discussion on a mailing list. But I'm seeing that people's main enthusiasm right now is to go find additional caffeine. So thank you for your patience through my squeezing of the schedule, because I had Friday and Monday mixed up. It's already that sort of week. We will resume on Friday for the appropriate time slot in those presentations. And meanwhile, set you free to your caffeine. Thank you for attending. If you have not scanned in the QR codes, please do so that you have a room big enough to fit us next time. Off by an entire half hour and I almost squeezed my way into it.
Yeah.
What I do is all these things, I'm trying to figure out when does the
Here.
finish.
Yep.
The tools should just do that for us.
The tools are not good enough.
I'm very careful about saying that because they tell you this is open source, no fix it.
Yeah.